Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper from the Hugging Face trending list, published on August 18, 2025, just yesterday. The standout finding is that GPT-5 shows unprecedented strength in spatial intelligence, yet it still falls short of human performance across many tasks. The paper is titled, "Has GPT-5 Achieved Spatial Intelligence? An Empirical Study." And as we will see later, the implications for evaluation practices and future model design are quite significant. Beyond the headline, the study standardizes fair testing, compares leading proprietary and open source models across 8 benchmarks, and pinpoints where the hardest spatial problems remain. Alright, this figure contrasts 2 tasks. On the left, a 9-cell pattern reasoning puzzle is shown, where both the model and a human select option F correctly. On the right, a 3-dimensional block structure requires a top-down view choice. The model picks A incorrectly, while a human selects B correctly. Building on the introduction, the visual makes a simple point. Strong general problem solving can coexist with fragile spatial skills in everyday layouts and viewpoints. Next, the figure lays out the 6 building blocks of spatial intelligence as simple icons, left to right. First shows metric measurement with labeled lengths. Then comes mental reconstruction, the imagined scene in a thought cloud. Moving on, spatial relations uses a ground grid with arrows for front, right, left, and behind. Perspective taking shows 2 viewpoints connected by a dashed line. Deformation Assembly depicts pieces combining. Finally, comprehensive reasoning traces a multi-step path with flags and clouds. Okay, this table compiles the 8 spatial benchmarks and what each one measures. A quick scan shows release dates, counts of images, videos, and question answers, whether chain of thought labels exist, how data was annotated, and which spatial capabilities are covered. Notably, MindCube lists the largest question pool, while Sight dominates in videos. Building on our setup, the capability column maps each benchmark to metric measurement, mental reconstruction, spatial relations, perspective taking, deformation and assembly, and comprehensive reasoning, ensuring coverage across complementary skills. Moving to the results, this table lines up 8 spatial benchmarks across columns and compares models row by row. The shaded cells flag top scores within proprietary and within open source groups. You can see GPT-5 leading most columns among proprietary systems, while intern VL378B frequently tops the open source side. Random choice anchors the floor, and the human row shows the ceiling, with wide gaps on MMSI and spatial viz, but much closer margins on VSI and core cognition. Continuing from those results, 2 takeaways stand out. GPT-5 pushes spatial skills forward, yet clear gaps remain in mental reconstruction, perspective taking, deformation and assembly, and multi-step reasoning. The standardized evaluation setup matters just as much, giving fair, comparable scores. That is it for this episode of the AI Research Roundup. I am Alex. Thanks for listening.